the in and out to Spark also has to be fast, right? So we are doing a lot of work in this space. So both Praveen and I, we are focusing, and then there are other people from within IBM as well as open source community who are building on this link between Spark and databases. Okay. So this is a brief agenda. So just to set the stage, I will talk for around 40 minutes. We will take a break. Hopefully by then the tea and samosas come. And after the break, Praveen will take over, right? So this is the agenda for today. I will do some level setting. A few of you are new. So I'll do some level setting and cover some background around Spark SQL and data frames, right? And then I will cover the need for connectors and what are the ones available in the industry and the ones that we are working on. And the second half of the session will mainly focus on code walkthrough, where you can see it in action, how you can develop your own high-speed connector for any data source. Okay. So I normally like to start with a use case. How many of you have heard about the weather company? And IBMers can put their hands down. Great. So weather company is an acquisition by IBM. We closed the acquisition few months back, right? And weather company owns things like Weather Channel on TV, and then online they have Weather Underground, Wonderground. So Weather Company is the largest private enterprise that is dealing with weather data, and they have the largest IoT data platform, right? They have weather stations spread across the globe, and they are the ones who are providing weather data to a lot of, to the top government agencies, energy, aviation, etc. Right? So you can imagine the amount of data they are collecting, and the weather data is constantly changing, and you will have seen in the last few years the accuracy of prediction has improved manifold, right? So that is just the amount of data that is being collected and the level of analysis that can be done on that huge amount of data, right? So if you look at the numbers around weather company, it is staggering, right? So they get, they have APIs they expose for access to the weather data. They get more than 30 billion API requests per day. Then they support all devices, all platforms. And as you can see, mobile usage is very high, right? Even people like us, we keep checking, how's the weather tomorrow, aaj match hai, whether it's going to rain. So all that is hitting weather data at the back, right? They deal with hundreds of petabytes of data every day, right? So it's, the volume of data is huge. They need to maintain accuracy, right? And they are using Spark as one of the technologies to power their data platform, okay? So they need to make sure that, they handle streaming as well as batch sources, okay? So as you can see from this diagram, streaming data arrives into this weather platform through a queuing service, and they're using parts of Spark streaming, and the data then is persisted into data sources such as HDFS and Cassandra. Okay. Then they also have batch data sources, which is databases as well as third-party data providers. They're ETLing that data out, right? And then they are storing it on Amazon S3. And they're merging the streaming and batch data. They're creating their own data lake, right? Which is talking to Amazon S3 again, as well as Parquet, okay? And then all this data, they are making it available to different tools and APIs through components of Spark, such as Spark SQL, right? So, the intent of showing this diagram is for one use case by one company. You can see that even within a company, the number of data sources, we are all in a very heterogeneous data source environment. they will need to talk to many, in this case it is Cassandra, HDFS, Parquet, S3, etc. Then there are a whole lot more. So, all this, even if this is fast, but if this link is not fast, it's no good, okay? So, I will not spend too much time here, but just to do some level setting before I delve deeper into the connector topic. Most of you will know that these are the 4 main libraries we deal with in Spark, and the focus for us, since we are covering the connector topic, will be Spark SQL, which is Spark's module for dealing with structured data. Okay, and of course there is Spark streaming if you want to build streaming applications. If you have data coming in from Twitter, Kafka, etc. Then of course the machine learning algorithms you can implement using MLlib, and then GraphX for graph processing, right? And as you can see, the number of data sources supported by Spark, either out of the box or specialized connectors that have been developed, and I will cover both in this session. So RDDs, all of you will know, but this is just for completeness. So this is the primary abstraction of data in Spark, resilient distributed data sets, right? And it is collection of objects spread across nodes in a Spark cluster, and it is very familiar. It is very similar to if you have worked with Hadoop, data being chunked out to multiple nodes in a cluster, and then the algorithm working parallelly on all the chunks. All those fundamentals are similar in Spark as well, right? So 2 main things when we talk about RDDs. One is transformations. That's how you create RDD, by applying transformations. And then other is actions. That's the end result you want to produce. And this will become clearer. I have used this example. So just a simple example where you have a text file and you want to count the number of times the term Spark appears in that text file, okay? So you ingest that text file into Spark using Spark context.text file, right? And the end result is a RDD. Now you want to filter all those records to only those records that contain the keyword Spark. So you apply the transformation, you apply the filter transformation, and the end result of that is another RDD. Okay, so lines with Spark is another RDD. But the eventual goal is to count the number of lines that has the word Spark, right? So you will apply an action and which gives you the count. Okay. Data set. For example, in this case, Hadoop RDD is one data set, right? But if you look at the physical representation, it is actually the RDD that is chunked and spread across the nodes in the cluster. But logically, to the application, it appears as one RDD. Okay. So a little bit more about Spark SQL. Spark SQL has been around since version 1 of Spark, right? However, the popularity of Spark SQL keeps growing, and if you just look at the amount of code that is being contributed to open source, Spark SQL is the most active component of Spark. Okay, so it is, like I said earlier, if you want to work with structured data or semi-structured data, you go with Spark SQL. You can use, there are 2 ways how you can query data using Spark SQL, right? You can either use the traditional SQL approach or DataFrame's API. Can I talk a little bit more about that? And you can write your apps in the 4 languages that Spark supports: Scala, Java, Python, and R. Okay, and here you can see examples. So this is from a Hive table, and this is a JSON file on S3, right? So you're just ingesting that, and it becomes a RDD, and you are applying if you're familiar with SQL, this is a cakewalk. Spark SQL module is a cakewalk. Okay, and you are able to query, you're able to join different data sources, and if you're working with data frames, it is very easy to aggregate, select, filter, all these operations that typically we do in the SQL world. So a little bit about data frames, right? So RDD was there. I mean, it was a basic data representation in Spark. Now they introduced the data frames API as an extension to RDD, and this was, I think, Spark 1.3, if I remember. Okay. So you can think of data frames as RDD with a structure. So data frame imposes a schema on top of your RDD. So it becomes similar to when you think about a table in your relational database. So data frame is conceptually equivalent to that there are rows of data and there are types, column types, right? And you can construct data frame from either existing RDD or a variety of data sources directly. So, behind a data frame, there is always an RDD you can get to. So, a simple example here. So, I want to construct a data frame from a Hive table, users, right? So, I invoke this API, .sparkcontext.table. I construct another data frame from a JSON file that is stored on S3. I provided Spark, right? So now I have two data frames, users and logs. Now I want to do things that we typically do in SQL world or any data query world, right? I want to filter out only those rows where the age of the users is less than 21, right? So the data frame provides APIs such as .filter, right? Or I want to do things like I want to count the number of young users by gender, so you can do group by operations and then apply a count, right? But most interesting is I created two data frames here. I want to join the two data frames, right, with a key, and that key in this case is user ID. So both my data frames will be joined, and the result will be one data frame, one joined data frame. And if you are more comfortable with writing SQL, then it allows you to do that as well, right? All you have to do is you do a register temp table, you register your data frame with this API, and then you can do a .SQL and issue select or whatever other statements, okay? So, why our focus on connectors and why the focus from other vendors as well as, open source community. So like I mentioned earlier, just having the compute engine is not good enough, right? The in and out also, that link has to be very fast, right? So whenever we talk about data movement from Spark, it is two ways. You have to be able to read data from data sources into Spark as RDDs or data frames, right? Because most of the querying on Spark or analytics on Spark is happening by ingesting data from multiple data sources, right? So you have to be able to load data fast into Spark from your databases. Similarly, you have to be able to write back, right? Now this probably has lesser usage than the first one. First is more of a reading from databases, bringing it into Spark. But this is equally important, writing back Spark data frames, right? And the reason is, once you have brought in data from many data sources into Spark, you apply a lot of transformations. You may want to persist it somewhere, right? So you want to write it back into databases, okay? So, Spark 1.6 that came out, I think, in January, improved the out-of-box support that is available for different data sources. Okay, so Spark 1.5 already had some support, but some things were not working. So 1.6 fixed a lot of the gaps that existed. When I say out of box is that just means you download the Spark jar and you should be able to connect to read data from databases or write back, right? With no other additional package needed. Okay. Now the problem is even with Spark 1.6, like I said, the types of data formats and the number of databases is humongous. So you may not have the support of all types of data sources, and even if you have support, there may be problems, there may be gaps, right? And that's basically functionally it should work. You download Spark, you should be able to connect to your databases. Then efficiency is the next step, right? So like I mentioned, you have to do, Spark is about bulk data, right? So it is very important that the data transfer happens fast, and for that, many vendors and open source community are developing Spark packages that provides performance optimizations on top of what is available in core Spark, right? So not all, although functionally you'll be able to work with Spark 1.6 to connect to databases and read data and write back, but that may not be most optimal, right? So, when I talk about out of box, meaning you download Spark 1.6 and you can work with your different data sources, there are many that Spark supports. Okay, here you can see an example, MySQL, Postgres, S3, HDFS. Now, there are areas we had found. We ran a lot of tests, and my colleague Smita is there. She was also involved in this exercise of identifying the gaps. This is somewhere around last year. We did this exercise where we just took, we started with 1.4 and also tried 1.5, downloaded it and wrote a bunch of test cases to test through. Of course, first priority was the IBM data servers, but ultimate goal is we really are not looking at only IBM. We are vendor agnostic. We want to move to more number of databases, right? So we wrote all these test cases to see if it works against Spark, read, write, different variations. So we found a bunch of incompatibilities, okay? Data type incompatibilities, for example, right? So Spark, Spark DataFrame API has its own API, and under the covers, it is generating the SQLs to talk to the database. You are not coding in the database SQL, right? So there were data types that Spark has, which the database server does not understand. And one very glaring example is the Spark string type, which by far is the most common data type in Spark. However, when you try to write a Spark string type into many of the databases, that operation will fail, right? And the reason is, Spark under the covers is generating an insert statement, and the data type of the insert is text, right? So not all vendors support text. Yes, MySQL supports, PostgreSQL supports, right? But many, IBM, Oracle, a lot of vendors don't support text type, right? So what do? Those SQLs just fail, right? And that's a very basic failure where you're not able to write back a string type, right? So we went through a lot of discussions on this. So text typically can go up to 64K is the max length of text type, right? So which data type we should map it to, right? That is available today in the database. Do we do varchar 255? But that is too small because text can hold up to 64K, right? Do we do CLOB? But then the problem is, the moment CLOB comes into the picture, then whether you should inline the CLOB or it should be external table space, those problems come, right? If we chose a higher length of varchar, if we went with say varchar 32K, right, then databases have the different page size limits, right? So you can't even do that. So, you know, all I'm trying to say, that seemingly simple thing, you know, that this test case is failing and we have to map it to some other type that the database supports. But the problem is you have to adopt a solution that is mostly generic. You can't customize it too much, right? Which will work for, the user is able to specify, you know, the type of mapping. I want to map to varchar 255 only, right? Someone else may want to map it to a clock with inline length something, right? So we did propose that to include that in the connection string or in the Spark config files, but the community is not very upbeat on too much customization there. So the solution is, you know, we do some generic solution in Spark core and then we start building our own package which we open source, right? So that's one. Now, even the other way around, when Spark is reading data from databases, right, even that we saw many failures, right? So just to give an example, in DB2 we have something called timestamp with time zone, right? So when you read it into Spark, you know, it was failing. You know, Spark doesn't understand anything about timestamp with time zone. So we converted it to string type or timestamp, I don't remember. But that's the kind of thing. Or we have something called deck float, right? Now Spark has no mapping for deck float. So things like that, okay? Then not just types, SQLs. Okay, so you write your code using the DataFrame API, right? But under the covers it is generating SQL. And you know, although we say that database vendors should comply with all these SQL standards, but we all know that the vendors have their own nuances, right? So for example, you know, some of them do not support, you know, under the covers Spark was generating to check if the table exists. It generates a select one with the limit, select with the limit clause, right? And not all databases understand limit, okay? So we had to do SQL mapping under the covers as well, right? And you know, as I'm saying this, not all databases will still work with Spark because this work is still in progress. I mean, we are continually adding code, but more has to be done in this space, okay? So what did we do when we noticed all these failures? One goal was, of course, there that we want out of box as much as possible. We don't want, you know, we deal with customers who don't want to download additional packages. They have very strict rules on, you know, the type of packages. So Spark is easy, right? I mean, Spark, downloading Spark jar is one thing, right? But if you tell them download these 3 other packages, it will raise red flags. So the goal was to put as much code in Spark core as the community permits, right? And whatever we can't build it in the Spark core, we put it in the extra Spark package, okay? So we put in Spark 1.6, you know, special dialect for the IBM data servers, and you know, there is still work to be done. For example, if I take Oracle, some of the things I mentioned will not work. Right, so someone has to pick up, you know, if we find bandwidth, it's just we are attacking one problem at a time, right? So we put in a JDBC dialect for the IBM data servers. And when I say IBM data servers, it is DB2 on mainframe, DB2 on the distributed platform, Linux, Unix, Windows. Then we also have DB, which is our data warehousing product for the cloud, for PaaS, right? And then we have Big SQL, which is the SQL interface to Big Insights platform, which is IBM Hadoop distribution, okay? So with this, you know, we have plugged most of the basic deficiencies that existed, but there is room for more, okay? We have to write more test cases and add more code. So that was out of the box, right? And that was our primary focus when we started this exercise, because customers were reluctant to adopt additional packages. However, there are many other things we want to do, and speed, enhancing speed. I'll give you a very simple example. Out of box Spark, when we started this exercise, inserts into the backend databases was one row at a time. So can you imagine in a production environment, right, where you're trying to write back your Spark data frames into the database, it's actually doing one row at a time, right? So we opened Jira and to add batching support in Spark code, so that was done. But we all know that batching is one level, we can go beyond, right? We can go beyond. And when I say that, most customers and database vendors have figured out optimal ways to deal with large quantities of data, okay? An example is, load, for example. Most of the vendors will have their own versions of load utility, right, to bring data into the database in bulk. However, Spark is not using that, right? Spark is just using bare minimum JDBC batching, right? So in the special package we developed, we expose Spark to some of the existing optimizations that database already has, right? So in our case, and we have put out the db2-db connector, it's already in open source, you can have a look at the code, right? So the two main things we did, and it is still work in progress, we are adding more features as we go along. And it is open source, any of you can feel free to contribute back to this, okay? So load, so we from Spark into database, it now goes through the db2 load utility, which is more efficient, okay? Similarly, for reading from database, right? Many customers have the database in partitions. Data is chunked, right? And they will have this MPP architecture where there's a coordinator node and there are these worker nodes with partitioned data, right? And out of box Spark, if it has to work against this kind of MPP architecture, right, it will bottleneck on the database coordinator node for reads. We want to bring data in from database, from a partition database, but everything will get queued against the coordinator node, right? So there is no reason why that has to be the case. So, the code we added was, we are allowing parallel reads from different database partition into Spark. So each database partition, it creates a data frame partition on the Spark side. Okay, so we are enabling that parallelism. Similarly, so this was, on the distributed side of things, we did that. There is work in progress for, different platforms. We are also looking at mainframe, for example, right? And as we're doing this exercise, we are looking through the stack where more optimizations can be added. So for the mainframe, for example, DB2ZOS, the underlying JDBC driver has a feature that is enabling a faster load, distributed load. Normally for load, you would expect that your file, with the data, exists on the server, right? And you run your load utility. So what we are now enabling through the underlying driver is your file does not need to stay along with the server. Your file can be distributed, right? And your fast load will stream data from the file through a TCP/IP connection, right? And then we are exposing Spark code on top that is making use of this fast load, distributed fast load. So, like I said, there are many in the community who are already looking into this, right? But it's just that the number of data sources is huge. So the scope of work is large, so it's not a done deal, okay? For NoSQL or semi-structured, you would have probably seen all these connectors that exist, CSV, Cassandra, MongoDB, etc. Then as far as structured databases goes, most of the connectors that exist today are JDBC based, okay? But there are efforts in progress to also look at alternative means where JDBC may not be the most optimal solution. Can you do a shared memory data transfer, for example? We are also evaluating at things, evaluating technologies like RDMA, right, for a in-memory data transfer, okay, with Spark. So I would just like to show this because this is another little project that our US counterpart team did, Spark Technology Center in the US. They developed a connector for Netezza. So Netezza is a data warehousing appliance, right? So all the concepts I discussed for the relational database, where you're reading in parallel from partition, for example, right, into Spark. So the same concept they applied to this Netezza connector also. In addition, it does things like predicate pushdown. So you want to have the database do more work on evaluating the predicate. It should not happen on Spark, for example, right? So we are trying to push down as much predicate evaluation to the database, which the database is good at, right? So again, this package is also open source and it's available on GitHub. The link is in the slides. Okay. Now, like I said, the number of data sources is humongous, right? So we are looking at some obvious ones, but there are many that enterprise customers are using. So again, taking the example of mainframe, right? If you talk about DB2 or IMS and those databases, they will work through JDBC, and we are trying to optimize these links, right? JDBC based links. But there are other types of data representation formats, for example, VSAM, SMF, which will not work with JDBC, right? So there are companies that are also providing connectors for these kind of niche data formats. So in this case, Rocket has built connectors for VSAM and SMF, right? So this is just to give you a sense that this effort is pervasive, right? Because the number of data formats and the number of databases that we are dealing with, that's huge, okay? Now, this is just some new work. It's not, I guess the colors are not very obvious, but to expose you to some other kind of new work that is happening, right? So we are developing all those connectors, but how does it fit into some other newer architectures that are evolving? And in this case, the architecture I am showing is a MPP architecture, right? So like I had mentioned, your data is partitioned across node and you have a database coordinator, right? Now the work that is happening here is wherever your database has either a worker or a coordinator, they are co-locating Spark with that, okay? Because there are certain queries that Spark can run faster than the database, right? So as you can see in this diagram, you have the database coordinator co-locate with a Spark driver, right? And each of the database workers are co-located with a Spark executor, okay? So the advantage of this is, your application entry point can either be Spark or it can be through the database, right? And between Spark and database on each node, they are figuring out which engine is the best to run that part of the query, right? They're offloading. For example, if a query comes to the database worker, it will offload portions of query that Spark can run faster, right? And why I'm showing this is this integration is making use of our connectors, right? Because they want this link to be very, very fast, right? Because they want to figure out on the fly this data is better served by Spark, so they have data transfer happening between database and Spark all the time. Okay, so I think it's 11 and I can see Sachin has arranged chai, coffee, samosa. Any questions before we take a break?
So eventually, are you planning to move all DB connection to out of box support?
That's the ultimate goal, but
So won't there be a overhead of maintaining this drivers in Spark? Because these many database connections, like I'm using Redshift for warehousing.
Yes.
So
they have their own package.
Yeah,
Amazon
they have
Redshift.
they have their own package. Okay, so this is not there is no out-of-box support for that.
Yes.
Okay, so and there is special commands in Redshift which can copy directly from S3 and many other sources.
Yes.
So this does not come in SQL. That is their own format, their own syntaxes. So if we are to support that syntax out of the box, whenever they are doing any changes on their side, there will be an overhead of us changing the code at our side also.
Yes.
I'm not saying that there will be backward compatibility, but still it will be an overhead always on Spark, right?
Yes. So good point. So there's a balance, right? We can't push all the optimizations we are doing into core Spark, right? But at least, for example, the JDBC based optimizations, right? Like I said, additional packages, for some of the enterprise customers, like the banking customers, they just don't get to download extra packages and use it for their applications, right? So at least whatever the community, this is again, we can propose and the community can dispose, like it happened for the properties we wanted on the connection URL, right? So there are certain core, see right now out of box was terrible, when we started the work with 1.5, 1.4, 1.5. I mean, imagine, like I said, inserting one row of data, right? Yeah. So at least you have to reach a level where out of box performance is also satisfactory and someone really wants a high speed, we will continue to have these Spark packages. I don't see them going away, right? But portions of that, which is a little bit generic to many database vendors, right? That we'll put in Spark core, okay? Any other question?
So out of box, all of them are still reliable or some of them are improved now with 1.6 and 2.0?
Okay. So with 1.6, it's already improved to use add-batch support of JDBC, where you can specify your batching, like 1,000 rows at a time, right? So it is big improvement over what it was at 1.5, where it was row by row.
So for reads as well, there is same, like how does, like if I compare to where it parallelizes the reads, right, into individual nodes, so does it go in the same way or is it still?
So out of box there is less parallelization, or very little parallelization, which is why when we are developing these packages, right, we are adding that parallelization logic. Right? If you have multiple nodes, data shared across multiple nodes, the reads should be parallel, but that doesn't happen out of the box today. Okay. Question?
The last slide talked about
This one?
mainly the database computation with the Spark. What is the reason behind this? Because in the previous slide you said that you are trying to put the predicates to the database as much as possible, and here you are talking about leveraging the capability of Spark to be faster. So is it that you realize some serious drawbacks over there in terms of performance for the database front end?
Okay, so you all heard the question, right? Okay, so the intent of doing this architecture is, like I said, there are some things that Spark can do better, right? Even functionality wise. See, database you can do normal OLTP or maybe complex querying, right? But if you want to analyze, for example, you want to join some data from database, and then you have portion of that coming from, say, social media, some count from social media, your number of friends, for example, right? And you want to join that with, transactional data, right? So that part where you have to look at, for example, social media, that the database cannot handle very well, right? Or even, I will give an example. if you want to apply some machine learning, it's just that whatever the Spark platform provides, right, it is much wider than what a database does. So the idea is, we marry the best of the database and Spark and give that option. Okay.
You can take an example like HBase. It has key lookups. So if where filter clause have the columns which are part of key, and you push those filters to the HBase. So it will be a pointed lookup for HBase. For a Spark, it will be a complete scan. You will pull all the data from the HBase, then filter out the data. So this is one example you can take it. So there will be multiple such databases which are very good at pointed lookups. You don't want to do filter on Spark on the pointed lookup databases. Like anything key value pair, where your key is in filter part, you want to push it to the database. You don't want to fetch all the data and then filter for the key.
Right, but there can be scenarios where inside your SQL you want to use things that the database cannot do very well. In fact, we're also working on features where from inside your SQL you can kick off Spark jobs. So that will kind of go along with this, right? You're writing SQLs, but there are functions available in the database which under the covers is firing off Spark jobs, and you can consume the results within your SQL. Okay.
So currently, is there any database which supports
This architecture? Well, I am not sure. I have not looked at all the databases. I doubt, if any exists where a relational database, for example, already has Spark co-located, right? But at least for DashDB, I know it is not very far. It is mid of the year. They will come out, June, July, they will come out with this.
Maybe I didn't understand or didn't get answered for the first question. Why are we writing down DB specific queries inside Spark code?
DB specific queries inside Spark code, meaning?
Let me answer this question. JDBC works, JDBC is a spec, right? It's a standard. But now let me pick up MySQL, let me pick up DB2. I say select star from something.
With one platform, right? You don't have to offload data somewhere to do your warehousing queries.
That's not the point, but dialect is something which is not new.
Okay, this is shifting back to what
Previously, it's not new, right? It exists from Hypernet IBM.
Yes, yes.
That's right. Why is it?
But we have to address similar problems with Spark, just like even today we are adding code for Hibernate, there will be problems, the difference, we belong to the JDBC driver team as well. So Oracle maps something to, for example, one data type, DB2 maps it to something else, right? So we need to constantly, make sure that, the Hibernate dialect is. Even now, we have outstanding requirements for you can't say that all problems with Hibernate is solved. I have a long list of requirements to add more capabilities to the Hibernate dialect, and we are going to put an IBM dialect in Hibernate now, right? So similar, so anywhere where there's a mapping, right? I mean, you're exposing the API to the application, right? But your database understands whatever, the SQL and the types. Wherever there's a mapping, there are bound to be inconsistencies. Right, so your point that it is very similar to Hibernate mapping, and although it works today, but not all works. We have outstanding requirements even in that.
To put it simple, right, this is something that will get to work with when you're reading the Arab. So when you take Hibernate as an example, or you take Rails it's all following adapter patterns. And adapter patterns are actually matched to different words. When that is the case, you need somebody who is handling this. That is where dialect comes in, and that is what applies to Spark.
Okay, thank you everyone. We'll take a break until what time?
15.
So 11:25 we reconvene? Okay, thank you.
And then there will be a code walkthrough for whatever.
Praveen will take it through the real thing. Thank you.
Okay, before I could get into code walkthrough, which probably for some it will be a bit dry session and some it will be a meaty session kind of stuff, we'll just have a quick recap of what we had in the first session so that we could have a session. Before that, how many of you use data frames here? Like have a hands-on experience? And when the session was explained, what exactly did you get out of what is the need for connectors or why is it needed? If you could, one of you stand up and say, or few of you stand up and say. Because I had questions just before the break, right? I had a few questions, so I just want to ensure that everybody are on the same place. I can take it from there. I take like, okay, you guys did not get why the connectors are needed, so I'll start back from the beginning.
The data from transaction data from exchange data.
Okay, and why was high-speed connectors needed? That we already are doing with out-of-the-box support in Spark, right?
Spark is only faster than connected. So, if
Okay, nice blanket section. Spark is faster and database is slower. No man, you can't be that slow on the database side. Spark is good for analytics and database probably for OLT. Any more answers?
when we load data into data frame, we can run it in distributed database. When we are pulling data out of database, it's coming as a single process. So it's very slow. It's a bottleneck.
Yes.
Only after we pull data into data frame, we get measure distributed process.
Correct. So yes, this is one of the advantages. So what happens, like Pallavi was mentioning about the use case, right? So you have so much data moving in from let's say 10 machines into one database server. How can I even parallelize that? Because definitely databases have been for a long time, or let me tell it as data server because database probably is more specific. Data servers have been for a long time and they would have optimized their way of working, right, for different types of workload. So now we need to look into what is the best fit for Spark that we could use for that particular database so that we get the efficiency that we are looking at. So one of the efficiencies as he was mentioning is like, I have a database which is like itself in a master slave configuration. I have master 1 and there are slaves 10. And Spark is also on that distributed mode. But when I try to do out-of-the-box support from Spark, Spark is channeling its query directly to the master of database, which means that from 10 systems I'm going to one system and then I'm moving back to 10 systems. So if I could parallelize even that part, that make use of the parallelism that the data source itself provides, then that is something will be beneficial for me to work with Spark. So at least I read operation. So if I know, I was explaining to one person here on how the query read works kind of stuff. If I just select star from table 1, and I know that table is partitioned in such a way that primary key 1 to 100 is on machine 10 and 200 to 300 is on machine 11. But if I could say Spark, instead of just saying select star from table 1, that query going to master and master of data source, so pushing the query to the respective slave. If I could know, okay, the query that is being issued is from 1 to 100, the where clause is from 1 to 100. Can I go on to directly partition number 1 of my database? So if I could issue a query saying select star from table 1, where ID is 1 to 100, from partition number 1. So I'm actually making use of that parallelism also. I'm trying to avoid the bottleneck. That is where your high-speed connectors come into picture. Okay, one of the use cases. The second use case probably I would say is when you're trying to insert data into a database. How many of you have used different databases? DB2, Oracle, MySQL? Which database?
MySQL, Postgres.
What is the efficient way of loading data into, say, MySQL? I have bulk data. You have, say, a dump in some CSV file. How are you going to load it onto database?
There is some connectors for that. Third-party connectors use that generally.
Okay.
Import visa.
Pardon me?
Import visa.
Import. Okay.
But I have seen some database wherein you can just issue copy or load command, and it will just take care of it.
Correct. So similarly, exactly. So let me take DB2 as an example because I know DB2 kind of stuff. So DB2 also provides a load command. What exactly it tries to do is it tries to write data directly into memory. If I need to go through SQL today, I need to go through the SQL parser, I need to optimize on the SQL, write it to my buffer pool, and then persist on the disk, right? So that is the process. But now, if I know my data is already cleansed and in the format that I need to insert into my database, why should I go through the process? That is where we will get into optimization kind of stuff. So, the load utility is going to help you write directly into the memory structure. So, with high-speed connectors, what we are trying to do is, if you are needing such kind of operation, such kind of optimization or efficiency in your insert, then, and you are definitely sure Spark has already handled your cleansing part of it. You analyzed it, you know this is the data that I need to put in. So how can I bypass this stack that I need to go through to finish up with my insert operation quickly. So this high-speed connector will allow you to make use of the load utility and directly insert into DB2 and you're quick enough kind of start to go on with your next operation. So that is one of the use cases for high-speed connectors. So given that we have said this, I'll take you to code which parts of Spark core things are available, how Spark is transparent enough for you to use any new adapter that is coming for your data source that you want to use. And then we'll open up for questions and we can close the meetup. So first question, first thing is like, given that I asked how many of you use DataFrame, this is for loading data from a data source into DataFrame. How many of you have used this code? Okay. So just for other guys to set the context. So these are normal import statements. As a developer, anybody will understand. This is the something you'll need to bring the class into scope, and then you can start working. And this is how you're going to start initialize your Spark context, the third and the fourth line. And the fifth line is where actual read of data is going to happen. So you can see on my SQL context, I'm saying SQL context.read, and I'm specifying the format to be as JDBC, which means to say now my read operation is going to be transferred to my JDBC driver, and I'm going to read from it. And I'm specifying different options. If you can see, there is one option which says URL JDBC DB2 DB server. DB server basically is a placeholder here. It says what is my database name, and the first two ones are the keys. If somebody in this data source world, you know what the first two terms mean, right? You're saying this is the JDBC driver I'm using, and I'm using it for the DB2's JDBC, because JDBC is a spec, it can't be a driver on itself. Then once that is done, I'm also telling what is the table name that I need to load into my memory so that I can perform my operations. So what this guy does is, he gets on to the JDBC driver, he creates a connection to the database while using the URL there. He says connection.prepare statement, he says select star from this table name, schema.table name, and he's just going to pull it out for you. Okay, so now I talked about the parallelism in routines that needs to happen. How can I do it today? So what we have done in the high-speed connector for readers, you can see this blue lines that is coming out, right? There are only two additions that you need to make, and I would not even say this is an addition because there's a replacement to whatever you have done here. So here what is happening, you're saying SQL context.read, it's still the same. Only thing that you're changing is you're saying the format. Okay, if you can see the difference, there we said format is JDBC, but here we are telling it's some class, com.ibm.spark.ibm data server. Why are we doing this? Why are we doing this? That is what I'll show what happens in the code, needing that it needs to do this one. Okay, so let's get on to the next slide that I have. Which once again is similar to the previous one, but the only difference here is we are trying to now save the data. That is, after my analysis, I am ready to persist the data into my database, and that is what is happening. This is your normal way, where you are going to say, here I'm for the use case sake, I'm saying just reading some data out of the JSON file and then trying to put it into my database. You'll say, as soon as you read, you got back your data frame. Now from data frame, you're going to say DataFrame.write, and mode, you're going to say append. How many of you know about the different modes that database provides? Spark provides, sorry. Okay, cool. to brush up once again what the modes mean and to others so that they get what mode means and then doing it. So there are 4 different types of mode if I understand. First one is the mode append that I am using here. The append mode says, okay, if the table already exists on the database, just go ahead and insert the rows to the existing guys. Then second thing is create if not exists. I don't exactly remember the keywords for that one. So create mode wherein it says, okay, create the table. Create if not exists is like create the table if it already doesn't exist and then insert data into it, or else just go ahead and insert data because the table already exists. Then there's one more mode which says create, which says go ahead and create the table first. Now if your table is already existing, you'll get back to failure. If it's not existing, it's going to create the table and insert. So similar kind of modes are there. You could go through the documentation to understand. The what difference, what I would like to show in this slide is, so this is the normal way of doing it. If you need to use the high-speed connector in here, it's similar to what was there on the last slide. What's the change?
Formatted.
Pardon me?
Formatted with IBM data.
Correct. So there are some package name that I've given saying com.ibm.spark data server, everything is it's quite transparent for the user. So what exactly is happening in the code is the interesting part that you guys will want to know. On our data frame, right? Whether like we got some options in the set format and then we can save. The control is going to come to the DataFrameWriter class, which is there in Spark. And what exactly he tries to do is he tries to resolve the data source. He at this point of time doesn't know what I should do, like which data source is the user connecting to. He just tries to resolve the data source. If you get on to the application or the actual place where he tries to resolve the data source, what exactly is happening here is he tries to infer the class at runtime. That is, create a new instance of the class at runtime. So if you could see here, there is this part where he says look up the data source from the provider. So actually what happened is when you did a load and provided the option, he would have set this provider string. This is nothing but the provider here is going to be your com.ibm.data server, IBM data server package. So now what he tries to do is in this lookup data source, he is going to find whether that particular package, and he requires that there be a class called default source implemented in that package. He tries to find that one. So finally what he does, he tries to find for a class called com.ibm.ibm.dataServer.default source, and he tries to load it up with the class code that he already has. If an instance of that is available, then he tries to get into that method, that is route all his calls, the operation calls into that class rather than using the default ones. So now what exactly is happening in this default source class? What makes the commonality so that he understands what is happening in the default source class is something we'll look at, I'll show now. That is what Spark is looking for, and it extends some traits or interfaces like for the Java and Scala guys, and it says there's something called the create table relation provider and with the relation provider. So what exactly are these traits doing is they are defining certain operations that mandatorily needs to be implemented by your source, the data source that you are going to learn, so that whenever the needed operation is called, let's say I do a save, he calls me the necessary method, which will, like for example, if I say save, the things that are needed is I need the SQL context, I need the data frame which has the data within it, and I should be able to know which mode he has invoked from, right? So those things are provided in these traits. Like there is something called as a base relation. First of all, he says any load operation will need to give back a base relation. Any class of type base relation, the base relation is abstract class, it needs to get back a class of base relation so that any further operations is going to invoke from that kind of stuff. So similarly, he has different traits that has been defined for different purposes. Like say, if I have a schema that is, if I'm connecting to a JDBC source, it definitely can create a table into it and pull out the data. So those kind of stuffs are defined in create relation provider and relation provider. For you guys to look at the different traits and what exactly they are doing, you could just get into this package called this package org.spark-SQL.sources. He has defined a list of interfaces, that is traits, that you will mandatorily need to implement in your code if you're trying to bring up your own connector to your data source. So as you can see, we have used this data source register. This trait helps you to know what exact data source am I interacting with. It tries to give you the short name. And then you have this relation provider. So this was one of the classes that we have, or traits that we have implemented kind of stuff. This guy says, okay, he takes SQL context and just the parameters from which we can infer the schema and try to build our data out of it. Then similarly, we use one more called as, there's something for Hadoop specific operations. And then this is something interesting because this was something that we, implemented in our trait, the class that I showed. It's called as the creatable relation provider. So this guy, if you see, he says there needs to be one method that needs to be overridden by you or implemented by you. This is at the top. It says, I'll pass you the SQL context. I'll pass you the mode in which you are going to save the data. Then I'll pass you the parameters that you would have provided as part of options kind of stuff. And then I would actually pass you the data frame, which actually has the data in it, the after analysis data kind of stuff. So now that we are, extending these traits and trying to implement it, what exactly can we do in our code? Here you go. So this is the method that we have implemented, right? Which has a SQL context, we get the mode. So what we do is, initially you could pass your different parameters that you got to get all the options that was specified by the user. Like he would have specified the URL from there, the table that he is trying to create or that he's trying to insert into. Then he's going to specify the username, password, and then the different properties that is needed to connect to the database. Once that is done, he tries to create a table if it doesn't exist based on the mode. I talked about different modes. So here you go. So here he first determines whether the table exists in the database. That's an easier way. He shows there's a command to do that. Different databases provide different ways of doing it. And then if you said same mode ignore and you say table exists, he is just going to run. He's not going to worry about what operation will I need to do. Then he says error if exists. He says if the table already exists, then error out. Then you have similarly same mode override. So override is an interesting mode. Like say you already had 100 rows in the table, he probably will just go ahead and drop the table and recreate it because you asked it to be overridden. So you can use it based on your need for that scenario. And finally, when he determines based on whatever mode was specified, he just goes ahead and creates a table, making sure it's ready for you to start using it. Once the table is ready for you, what we are doing in this case is we are creating a class called IBM JDBC relation, and before I need to switch back from that mode to this mode, this guy has a save table data. So what we have done here is, the data set that we are using, we definitely need to reuse the JDBC constructs. There is nothing different that you are doing. So it's only an extension that you are giving to it by changing the save and the those methods. So what we have done is we have just pulled out a return class called JDBC relation, which extends JDBC relation so that we get all the functionalities there. And we just try to override the necessary methods. For example, you saw we were calling a method called save table data. Okay, so this guy now he tries to get the dialect out of the URL that we have passed. So if you remember, the URL that we passed was saying JDBC colon DB2 colon and the database server name, right? And the DB2 there determines which dialect that we need to use, and he's going to load the dialect that we have in Spark for DB2 here. And then what he does is, this is the JDBC type mappings. So if you can see, this is this JDBC dialects class that the Spark core gives it to you by default, and it has a list of methods. So wherein he says, what should I do when some particular kind of what they say URL is given to you and I should dialect. So based on the registration that we have done here, DB2 dialect, he is going to push back the DB2 dialect instance to use, from where you can get the actual JDBC type mappings. So if we could just switch on to the other file. Sachin, is there a better way to switch without getting onto the presentation? The dialects, as I said, are going to have the different database types and the mappings from the Spark types. So once that is available, what you do is you say DataFrame for each partition. That's the way you try to pull out data, right? And when you say DataFrame each partition, you are giving a snippet of code that's going to get on and run on each of the executors. So what we do is, in our case, we say DataFrame each partition, and in that we are going to call a method called a save partition, which is going to pass a connection method so that each executor now gets to open a connection with the database. And then what we do here is we try to get the database types out of the RDB schema. When DataFrame gets created, it tries to infer the schema that is there for your data automatically, and that instance of that is available to you. So now picking up the RDB schema, you know what the type of data that is available, and based on that type, you're going to map it to the database type that is here. For example, if you see it's an integer type, then what I'm trying to do is I'm trying to load the integer. That is, I'm trying to get it as an integer out of the RDB and trying to load it into the database. So this is where this is how you could pass the different data types and insert the values. So in our load operation, as I said, load utility was very faster. So what we tried is we pulled out the data from the data frame, wrote it into a CSV file on each of the executors, then issued a deep load command including that CSV file so that we could fastly get in the data into the database. So similarly, what you could do for parallelism is database with your data sources provided how many partitions they are lying on, so that you could get each of the partition numbers from there. And then when you are trying to issue query, which Spark already is providing out of that, you could say these many JDBC partitions are available, so that you could append some form of a query to your actual SQL that is verified. So let's start from table 1, and then you could say from partition number 1 to 3, so that the queries are directly routed to your partitions and they are brought back into the Spark code. Okay? Any questions? This is the code that I had to show for you guys to try out and look at it as an example. You could just get on to our github.com/spark/tc/sparkdb2. The code is entirely there. You could see how we have implemented reusing some of the features of Spark already present, and then you could feel free to ask doubts kind of stuff on the meetup blog or raise issues on this one. Before we could close, do you guys have any questions on this one or any generic for today's topic? Please go ahead.
First one is how do you get to know in which partition you data lies? You see which one is it.
Right.
The reason is when you do the horizontal scaling or you shadow the database, most of the database has smartness to automatically balance the data depending upon the load and content the individual partition has.
Correct.
So that becomes a challenge because the straightforward use case, what you said, like taking the key from 1 to 100 and one point out, that would fail out in case of database just that balance. The second case which I see here is you said like the code what you have written out here will try to write it into a CSV file and then it will try to load it into your so wouldn't there be so in this case if I understand correctly you are doing it on either an one by one call or max it would be a batch inside the system.
When you are saying one by one call, what exactly is it?
Maybe an individual record. Is it an individual record or is it
No, batch record. No, it's like say when I say DataFrame.for each partition. So now your control is moved on to all your executors of Spark. So entire data that is available on that particular executor is going to get done from.
I got your second question. Second question I can answer. His second question is when you are writing it to a file, every partition you write to a file creates a CSV file, then upload the CSV file to DB. So he says that there is an overhead in this. Why you are doing this? Okay, so load utility capabilities are there, which we are using here, which is much faster than inserting a row or much batch. So the load utility enhances it so much that the write overhead of the CSV file is taken care of the load utility. And
It's quite negligible.
It's quite negligible. And we are enhancing the load utility to take the data from memory instead of a file. And that is done by some another team. So until the team gives us the enhancements, we have to do by this way.
If you could actually get in and look at, if you try to play around with the code, there is one more construct that you'll see. There's two different same partitions that we are trying to parallelize it. And today, if you take JDBC batches, it's going one batch at a time on the executor. We are trying to parallelize that one also, take like not one batch, multiple batches at a time. And we tested both those scenarios and we found that load is really faster. So the time that it takes to write CSV to this, and given that it's from partition, the amount of data that you're looking at is, let's say, n divided by the number of partitions. So that write into CSV file was very, very efficient.
Yeah, this load utility is something specific to DB. If the writing to CSV and using load utility may not work if your tool does not have that kind of load utility.
But what if you don't have bulk of data ready with you? Say for example, it comes at
So we are talking about extremes right now. past 3%. So then every stream also gets back. Every end of the batch is so streaming will also get back. Once the batch is complete, you are defined your time. Data will be fine. And at that time you go to the execute. No system of data. May I ask you how you find this management? No, at this point, I get your point. But I'm getting to continuously, and there's only let's say for that particular hack or for that particular event costing you got 10 euros. So, am I doing those creating just for that 10 euros? At this point of time, yes, but now if I'm trying to integrate your kind of application, then probably what I will do is I will modify my IBM data server report. So, let's say that is the something let me also wait for instance amount of data to come in. Because given that you're already doing 500 project, actually it will be okay to say responsibility. That definitely can be handled, and so something you feel as a
Also first party are how is that?
Thank you. did that testing and we were able to get almost like somewhere around 50% of the I think around 40%. With our loading to recover the I would say for the last of both, now, it really depends on how much data is down. So, it will be a company we can run it with but if you, I really can't do something like that because I don't want to compare
Actually, you know, if you want to go deep, there are settings even in the agency driver where you can utilize control. Not in what is exposed to the application is just the logic of the transfer socket call being done by the underlying data. It has its own checks and balances, right? And the default of this is that the application doesn't use the control. This is not very different than multiple SQL or Apple or so nothing is hard that you need to do to underline it. But at the same time, you want to build a connection to the logical connection to your Java, object which is created
load and reserve because instead of obtaining and just another more.
That's definitely possible, but it's not straightforward because the standard code that the focus of the function and one database actually it's not going to be on the master or master. So what is that is theoretically definitely possible, practically as I mean, it's not like not doable, but it has some things that we need to take care of, and then
the property of the option that you are if you want to
the options are more for you to understand the database you are going to what vendor and different URL connection properties are going to be good part, but we are not part. And when we pass, definitely we can pass the number of connections that we need to open up. Now, in the future, now you need to have connections open up every user plan or connection on server. That's right. So if we give line of it is common tool for all the that may not not usually whether not usually. So if we need to open a connection tool, definitely we need to open it on a tool. So we need to say here you know actually party the things of both program, right? So when we are party that we can enter how to addresses these that is giving these collection volume by one day, and we can enter all the institutions have a institution collection volume strategy of each other, which is a package there, and we need to say okay, we use this much, we use this much.
The number of connections we that more than 4
So that was the question which can be mounted. If I am going to pass the property to this, I can do this. Or I can say, if we are going to say it's going to be for the entire institution, I can just say that you can tell you what is the number of
Generally now, we is taking only one connection, right? Spark is having only one connection to database. Like a database like MySQL and Postgres. Even if you have thousands of executors, Spark further, it's taking only one connection to
no.